Now let's talk about integration. Let f, g, and h be integrable, real valued functions over a closed interval a, b. The indefinite integral of a vector valued function rt being ft, I, gt, j is so. We also have definite integrals which have bounds on them. So none of that changes here. Just like we had the component-wise derivatives, we have component-wise integration. So this is actually very simple for us to do as long as we know how to integrate. So if we look below here, it says given RT equaling 1 over 3t plus 4, comma e to the negative t cos of 2t, and it says find the integral of rt dt. So what we're going to do is we're just going to integrate this. Now, one thing to keep in mind here, and I don't really show it up top either in any of these forms here, when we actually integrate, do not forget your plus c. Now, one thing about these, since we're integrating component-wise here, each integration is going to have its constant that we have to add to it. So you can call it like C1 for the first, C2 for the second, C3 for the third. And you'll see how that all plays out when we get done with this problem. Okay, so anyways, let's get started. So we want the integral then of, and I'm just going to take the first component, the f, the little f, and dt. So I'm just going to integrate this. This would be a u sub if you weren't comfortable with it. We'll do a u sub so you can see how it works just in case you forgot. This is going to be 3t plus 4. So then my du equals 3 dt. So then dt equals 1/3 du. So then when I sub that all in here, I'm going to get 1 over 3 of the integral 1 over u du. And we know 1 over u is the ln of u. So this is going to be 1/3 ln of, and we have to use absolute value here because we can't have a negative that we're taking of our ln. So we end up with this as our first function. And don't forget your c, call it c1. Just because it's the first function, so we're going to call it c1. So there's the first one. So I can just say equals, and I could write in here 1/3 ln of 3, I was going to write an x, 3t plus 4 plus c1. Now the next one is a little easier. That's just e to the negative t. And when I integrate e to the negative t, we know e to the t, the derivative is e to the t. So when we integrate here, it's just going to be negative e to the negative t plus c, 2. So e to the negative t plus c2. And then for the third one here, we're going to have cos of 2t. So that means we're going to integrate here. So the integral of the cos of 2t dt means when I integrate cosine, that's going to be a sine of 2t. And I have to account for the 2, so that would have been a chain rule also, so that would have been a 1/2. Because when I differentiate this, I'm going to get a cosine 2t, and then I got to take the derivative of the inside of the 2t there, and that's going to be 2, and that cancels with the 1/2. So plus c3. Oh, I don't think I'm going to be able to fit it here, so I'm going to have to move it around a little bit. So 1/2 sine of 2t plus c3. So there's our answer for that integral. There we go.